So what we're talking about today is what's being called the gut-brain axis. A recent article, they called it the gut-brain highway. And we're going to look at that in more detail. And interestingly, Hippocrates had a glimpse. All disease begins in the gut. Now, I'm not saying all of it does, but over 2,000 years ago. This is a simple graphic of the gut-brain axis. We know our brain can control our gut. If we're very anxious, we kind of feel it in our gut. If we have to clear ourselves, we direct. So we know this part of the axis, that we have some control over our abdomen, or gut, if you will. It's this that we're learning about. It's how does what happens in the gut affect how I feel, how I think, etc., in diseases of my brain. So we need to dive in. Brain health largely depends on the GI tract. Now, if the intestines house 70 to 80% of our immune system. If you're a country and you're going to devote 70 to 80% of your defenses in one area, you know you've got a problem in that area. So the body is doing that, okay? And we'll look at why. And so this is the nitty-gritty slide, if you will. We're going to expand on all of this, but for us to kind of delve into, okay? This is the inside of our intestine. This is the outside world. This is what we put in our mouths. It's all coming in from the outside. So what happens is very dependent on this, and I'll show you the connections in a minute. Some people call it the second brain, if you will. So what I want you to look at is these little villi where all the action happens. We're going to dive in and understand the battleground, so to speak. So we have microvilli in our gut, okay? We'll have 6,000 to 25,000 per square inch. If it was all laid out, it'd be 30 square meters. That's how much absorptive surface we all have, okay? And each microvillus has a nerve, it's the vagus, and it has an artery and a vein, okay? This is a healthy gut microvillus. What is in those crevices? Why is this surface even there? Because things are in the crevices. We put the food supply that goes down here, and we have trillions of bacteria in there. Okay? We cannot live without them. We need to nurture the right bacteria or we're going to get sick. And I'll give you some examples. So estimated over 100 trillion microorganisms, over 10,000 different species. As a neurologist that specializes in this area, Dr. Perlmutter says, put simply, they are in charge of your health. So the gut absorbs nutrients, detoxifies, builds some of our neurotransmitters, and builds vitamins. What doesn't show here is one example, which is serotonin. Serotonin, about 70% is created in our gut. Serotonin, some people know as the feel-good hormone. So if your gut's not producing adequate enough, you're not going to feel good, to put it this way. What does it do? It regulates mood. You feel more emotionally stable, less anxious, more focused, happier, and calmer. It regulates your appetite, your sleep. In a recent rat study, the speed of your memory. A deficiency of serotonin, if it's not built enough in your gut, depression, anxiety, panic. Recent report, possible role of serotonin deficiency in ADHD. So this highway that we're talking about, one of the key is the vagus nerve. It goes not only to the intestines, but to the liver, et cetera, okay? The vagus nerve is the primary channel of information between the hundreds of millions of nerve cells in our intestine and our central nervous system. So that now we're knowing the signals can go through that nerve. And here's the but also to the blood vessels. And here's where the battle is fought all the time. We just had lunch. It's being fought seriously right now, okay? And that is, we know the brain can control the gut, but we're now learning, or these docs are now learning, and researchers, that what's happening in this battleground is going to affect how we feel, how we think, and neurological diseases. So we're going to now focus on this a little bit to understand that. This is just in May of this year in Nature, a top world publication. We're now getting ideas of how it affects the brain cells. From the gut, the bacteria create various metabolites. That's a general term. We should learn that. It's metabolites. There are all kinds of different things, okay? Metabolites can affect our immune cells of the nervous system. They're called microglia. They're actually quite small, but they've drawn them large here. Depending on metabolite, the microglia can inflame your astrocytes, or could de-inflame them, if you will, calm them down. So this metabolite is what I'm saying, the reason this is so important is that now we're seeing some of the pathways laid out. How does it affect our astrocytes? And why are the astrocytes important? They're going to regulate our synapses, the neuronal firing, and they protect the nerves from oxidative damage. So if our astrocytes are inflamed, our neurons aren't going to work as well, and they'll be dysfunctional. Here's a summary. The brain inflammatory cascade is controlled by gut-derived molecules. Wait. I'm here to learn about Chiari. What does the gut-brain axis have to do with Chiari? Okay. Well, think about all the myriads of symptoms that are part of Chiari. And these are the ones I've pulled out of that long list. Y'all can all look at them and see. How do we know that somebody presenting with Chiari, that all these symptoms are due to the Chiari? Because obviously neuroinflammation is widespread. It's common in a lot of us, okay? So if you're having poor memory, brain fog, poor sleep, you didn't recover fully as you expected after surgery, let's dig deeper. There may be something else. And so that's why we need to learn about neuroinflammation, is what it's called. The inflammation that begins by what we put in our gut and how the intestines. The best known example of this is celiac disease, and I'm going to go over it with you just a little bit to show you the battleground in action. Okay? Celiac disease is an allergy to gluten in genetically susceptible individuals. Before farming, we did not consume gluten, or before agriculture, we did not consume gluten. Gluten came along with farming, and those that were not gluten allergic had more babies. The others were sicker, okay? So the human population over time, there are less and less people that are allergic to gluten. So many people can tolerate grains, but still today, some do not, and there's a big battle going on, and this is where we've learned a lot. Now, there's a whole bunch of symptoms, for instance, short stature, etc., failure to thrive, but there are neurologic symptoms, irritability, behavioral issues, ADHD, fatigue, depression, peripheral neuropathy. We heard a lot about that today. Seizures, headache. So it's a common disorder. This is a nice illustration of the battleground. Those are those little villi. That's the outside world. This is what we put in our gut is here. This is the healthy lining. And they have these little tight junctions. And gluten is trying to get in. What gluten can do, the gliadin protein part of gluten, is it breaks through. It's not trying to metabolize through the cell. It breaks through. The gut is sending a bunch of inflammatory molecules to kind of plug these off. These are lymphocytes, to plug these holes. If it exists long enough, the cell lining is destroyed. You've heard of leaky gut. It's not that our gut is our insides are leaking out. It's that the bad outside world is leaking in. It's getting into us, if you will. So again, people with gluten allergy, and gluten is in grains, especially wheat and dry, and it destroys the internal mucosa. Fortunately, we have these tight junctions right in the gut, but gliadin, the protein, the gluten protein, can break into it. Lectins in grains and beans can break in, glycoalkaloids in potatoes, and they also inhibit the breakdown of bad things, if you will. So what happens to the gut? Villi. This is a micrograph of an actual villus. This is healthy. There's a break-in here. There's a break-in. Those inflammatory cells are having to be produced. They're trying to block the insult, but 42,000 children still die each year from this disorder, break-in of gluten into our gut. But fortunately, we have a, quote, blood-brain barrier. And so it's not going to get into the brain, right? Well, unfortunately, they have tight junctions, and there are ways now that that stuff is breaking into the brain, in particular through weak lectin, and there are others in a book called Brain Maker that I need to review. But here's the nitty-gritty. Gluten is broken in. What does that mean to me physically? Why should I worry about it? Well, one of the worst conditions is gluten ataxia. The gluten antibodies attack your normal major cells of the cerebellum. So this is an autoimmune disease. Your body's trying to defend, and unfortunately it mistakes some of our normal tissue and it destroys those. That's autoimmune. Our immune system is working against us, and it's knocking out the Purkinje cells, and that's a bad ataxia, difficult to walk, headaches, difficulty with speech. Or if it hits your spinal ganglion, you're going to have numbness, tingling, incoordination. Or if it hits your peripheral nerve, burning, numbness, tingling, pain in the fingers, toes, incoordination, and weakness. So a lot of neurological. Now, people say, well, yeah, okay, I understand celiac disease, but what about this gluten sensitivity? People that don't have celiac disease, are they really sensitive to gluten? Well, some seem to be sensitive. Here's non-celiac gluten sensitivity. 14-year-old girl presenting with psychosis. She sees people coming out of the TV to scare her. When she goes to sleep at night, unusual hallucinations, gluten-free diet, and she's asymptomatic within a week. So let's get down into the disorders that we're here to kind of discuss and know that some of our folks with Chiari malformation and some of us without Chiari malformation may have. One is obviously depression, right? Inflammation and depression. I learned that depression was a psychological disorder, but how many people you might know that are depressed and they don't really know why? Well, the scientists are telling us we need to start thinking of this as an inflammatory and degenerative disorder. Yes, a serious life event can make you depressed, I understand, but chronic ongoing depression is probably not psychological. It is the clinical expression of inflammation from central microglial activation. So the other term, you've learned metabolites. Microglia is something we need to kind of begin to think about. There are brain immune cells that are trying to work for us, okay? Here's suicidal thinking. We lost two prominent people a few months ago to suicide that were in the press, right? We wondered what was the psychological issue going on. We didn't wonder, is it neuroinflammation? So the anterior cingulate gyrus processes emotions and behavior. They did a fascinating study. It was only in 14 people with a major depressive episode. They put them in a PET scanner and looked for a protein marker of inflammation of the microglia. We're back to microglia. In summary, basically what was interesting is in the 9 people that had suicidal ideation, they actually thought about it, those were the ones that had their microglia inflamed. So you could now do a test, a PET scan, to see how is somebody, if they want it, do they have suicidal ideation? So the inflammation is correlating with this desire, if you will. And so, again, to me, this opens up a whole new way of understanding how we can help folks in this condition. Fortunately, there's good news. Whole foods lower the risk of depression. Over 3,000 patients, they either had a processed food diet or a whole food diet. Mean age 55. People who ate processed foods more likely to be diagnosed with depression. They noted a whole food diet heavily loaded in vegetables, fruits, and fish was protective against depression. Okay? Memory and thinking. A high fructose diet alters your brain's ability to learn and remember information. Fortunately, omega-3 fatty acids minimize the damage. Unfortunately, high fructose corn syrup is even put in our baby food nowadays. Inflammation and thinking. And I want a new term, or a term to remember also, is C-reactive protein. We'll talk about it several times. What about your thinking? This marker of inflammation, HSCRP, in stroke-free individuals, over 400, a high CRP correlated with difficulty executive thinking, which means planning, decision-making, and self-control. So if there's someone with an issue there, we want to know what their CRP is. It might be because they're inflamed. Their brain is inflamed. And unfortunately, a high CRP is associated with actual disintegration of some of the frontal pathways of our brain, which we obviously don't want. Okay? And then another recent publication just this June in Nature as well, and it is the speed of memory is important. Basically, the hippocampus is affected, our main storage area for memories is affected by what's going on in the gut. Dementia, you know it's a severe problem. Excess dietary carbohydrates, particularly fructose, along with a deficiency of fats and cholesterol, which we were misled by the McGovern Commission at the end of the 70s, that we were supposed to be afraid of fat. And what did the food companies do? They put in a sugar in the food, more sugar. And what do we have now? An epidemic in diabetes. This leads to cholesterol deficiency in the neuron, which affects brain function. Now, we test for prediabetes in our neurosurgical clinic, and some people ask me, well, why are you looking for diabetes? Okay, I think it's a responsibility of all physicians, because diabetes, I'll show you later on, is an epidemic. It's a responsibility of all physicians to do some of these basic tests, because they're not being done routinely in the primary care setting. So they looked at people that didn't have diabetes but had pre-diabetes, and sure enough, it increases your chances of dementia. So we need to find pre-diabetes for two reasons. One, it can be bad by itself. Two, I don't want to find out when we have diabetes. I'd rather know before so I can begin to make the changes then. Okay? Fortunately, again, we've got guidelines now that can help us. Now, ketotic diet is specialized. I'm going to touch on it later on. I don't generally recommend it right off the bat, but ketosis enhances memory and mild cognitive impairment. Very low carbohydrate consumption can improve memory in Alzheimer's disease, and this is the study here. Probiotics, they took two groups and they made a mix. One was milk and another a little drink of probiotics that looked like milk. So it was a randomized trial. It was small, 30-in-each group. But the group on the inflammation-reducing probiotics did not decline brain function, but actually improved by these scores, and they said that's a huge improvement. They were surprised that probiotics by themselves could make such a difference in this randomized blinded trial. Parkinson's disease. Dr. Parkinson, James Parkinson, in 1817 described the shaking palsy. He had 6 cases. Interestingly, one of his cases got better if you treated the gastrointestinal problems. And wouldn't it be fascinating if somebody would have carried this little nugget 200 years ago and helped us understand that it started in the gut? It's only now that we're waking up as a scientific community, oh, Parkinson's seems to start in the gut, okay? So let's look at Parkinson's. It's believed to be caused by, chronic low-grade inflammation in the gut, which results in blood-brain barrier leakage. Okay, we've got leaky gut. Now we're learning about leaky brain. It's leaking into the brain, and neuroinflammation in the brain. So bottom line is what they're saying is we may have a marker to predict who might get Parkinson's disease by just simply looking at their gut and testing this marker. Here's a recent review for anyone who's interested, recently published. There's a new one that I just saw the other day. Does Parkinson's begin in the gut? And here's what they say. The vagus nerve may be the primary route through the pathological triggers of Parkinson's travel from the GI tract to the brain. Microbes could be acting through metabolites to activate microglia, the immune cells in the brain, terms that now we should be getting a little more familiar with. So this is there's a lot of work being done. It's hard to keep up with this. Frankly, every week I'll find something online as to new work. We're going to learn more. It's probably more complex even than this. But clearly, from different directions, we're learning that we have a whole new area of health to focus on. And ketone infusions in mice partially protect against this neurodegeneration, and that keto bodies may be a novel neuroprotective therapy for Parkinson's disease. If somebody has it, then obviously you want to think about a ketone leaning nutritional approach. And then there are many others. I can't go over all of them, so I'm just going to give you a list. These are disorders that research is at least underway, looking at neuroinflammation as a possible underlying cause. ADHD, anorexia, autism, anxiety, chronic fatigue, obsessive-compulsive, pseudotumor, and some of the others, even Tourette's and schizophrenia, frankly. So why the decline in human health? Okay, our hunter-gatherer ancestors were actually healthier and taller than we were. Yes, they say, well, they didn't live as long, and that's incorrect as well. The average age in the late Paleolithic was 35, and that dropped down into the low 30s in Roman. The worst was during the Black Plague with an average age of about 25. It wasn't until the 1800s that we beat the Paleolithic lifespan. We beat it by controlling infectious disease and delivery of children, basically. There's 2 of the main areas. So the 4 reasons, which I can't go into in detail, each one of these is a lecture, is the agricultural revolution. Farmers are shorter and sicker. Unfortunately, Freud's nephew, Edward Bernays, he thought that people were irrational, and basically in the early 1900s in the U.S., the goal was to convert us from citizens to consumers. If we would be turned into consumers, we would be more easily controlled, is actually the thinking at that time. And the way to do it is by psychological marketing. And it's not buy what we need, but let's make people want things and keep them. And again, this is a whole talk by itself. And again, I've mentioned the McGovern Commission that falsely villainized fat. And then another reason we got into trouble is the food pyramid of 92. I will touch on that in a minute. But how can we reclaim our health? I'm not going to go in detail in the ancestral diet, like I've done in the past, but we will touch on it a little bit. What can we learn from our ancestors? So the book I read was by, called The Paleo Diet, you saw it earlier. It was by a professor of health and exercise at Colorado State University. He's one of the world's leading experts. He published the Paleo diet in 2002. I happened to find it in 2003. A very extensive bibliography. The key thing is he analyzed hunter-gatherer societies that were still around, and some are still around, over 200 or about 200 hunter-gatherers. What did they eat? Why was their health better, if you will? Then the first book on this textbook, medical textbook, is by Staffan Lindberg from Sweden, published initially in Swedish in 2003, U.S. edition 2010, over 2,000 references backing up the argument of what we think our ancestral health was like, okay? But one slide to me shows it all. Look at these little boys, okay? And this just happened to be one I ran into. They're Kitavans in the Trobriand Islands. They've ate their ancestral diet. They continue their ancestral lifestyle. That's how they look when they're young. The thing is they live a long, long time. This is a 100-year-old Kitavan, okay? And when Lindeberg looked at, although it wasn't a super detailed study, when he looked at of the 6,000 Kitavans, there was no sign of dementia. So dementia is viewed as a Western disease. Just let me summarize it by that. Now, you might say, okay, this is all out in the public and fad and all this and that and the other. But we've got a journal like Diabetes, Metabolic Syndrome, and Obesity saying that when compared to ancestral diets, the modern diet with dense acellular carbohydrates promote an inflammatory microbiome and may be the primary cause for, in particular, obesity. When they looked at ancestral foods, virtually all ancestral foods have markedly lower carbohydrate densities than flour and sugar-containing foods. A diet of grain-free whole foods may produce a microbiome consistent with our evolutionary condition and explain the benefits of the modern Paleolithic diet in satisfaction, that's satiety, and metabolism. So there's certainly medical backup. Now, if you want one nugget to begin to kind of think a little more about what we consume, look at the omega-3 to omega-3 6 ratio. Think about, is your oil that you're using to cook or the product you're consuming, is it high? We need both of these fatty acids. Our brain does. But we need them in balance, roughly 1 to 1 if we can get them. Unfortunately, our diet is very heavy. And here's a high omega-6 to 3 found in today's Western diet promotes the pathogenesis of many diseases, including cardiovascular, cancer, osteoporosis, and inflammatory and autoimmune diseases, okay? So here is the ancestral diet pyramid, okay? This one is by Mark Sisson of Mark's Daily Apple. He calls his diet the primal diet, and basically vegetables and fruits are at the bottom, as in other words, have a lot of vegetables and fruits. That's a 1 to 1 omega-3 to omega-6. This is the pyramid we were sold in 1992, and only recently have they finally retired. Very inflammatory, high omega-6. What I read, and I haven't gone into depth, is there was a lot of pressure from the industry to get this down as our basic foods supply. And I think the final thought I'll leave you with is take care of your gut. The gut takes care of you. Thank you.